Welcome to the Topographic Maps video with Mrs. Lehnert at HSHM. You should have your input page for topographic maps in front of you, as well as a pen or a pencil. By the end of this video, students will be able to describe how topographic maps show the shape of the land, and you should be able to interpret a topographic map. So we're going to kind of go on a little trip just for a little bit here. A couple of places we're going to visit. The Badlands in North Dakota. That's the picture in the left there. That's me on our little trip a few summers ago out to North Dakota. And then on the right-hand side, we're going to go to Devil's Tower, Wyoming. That's my husband and our car that we no longer have. And then there's a tall tower in the background there. That's actually the remnants of a very old volcano. And so that's like the inner core of the volcano that's left. All of the rest of the volcano has eroded away. It's gone away. The weather and the rain and everything kind of washed away the rest of the volcano. So we're going to go to these two places. So we're going to first go to Badlands, North Dakota, that first picture. This is a topographic map of that area. What do you notice? Hopefully you can see that there is water, right? The water on any topographic map is going to be blue. And the other thing that hopefully you noticed, at the very bottom there's a scale. And that scale shows you the distances on the map. So whether or not you're dealing with miles or kilometers and how far that is on the map. Another thing hopefully that you noticed is these numbers on the bottom here and the numbers on the side. Those numbers are latitude and longitude numbers, and you can see them in the corners here too. And then hopefully, I'm sure, the thing that you probably noticed right away were all of those little brown squiggly lines. They're everywhere on this map. And those lines are really the most important part of a topographic map, and we're going to talk about those today. And here's another map. This is the one from Devil's Tower in Wyoming, that old leftover volcano. And you can see here's the tower right here in Wyoming. And you can see there are a lot of those brown contour lines right there. And they kind of form little circles. Anytime you see circles like that on a map, it's a hill, right? The tower is a really, really tall hill. So now that you've seen a couple of different topographic maps, we should probably talk about and define what a topographic map is. So a topographic map is a map that shows the topography of an area. I guess we need to know what topography is then. So topography means it's the shape of the land. So is it really hilly? Is it really flat? Are there a lot of valleys? Right? In the picture here on the right-hand side, you can see there's a big valley where the river is running through it. And there are lots of hills on the left-hand side. So that would be the topography of this area, the shape of the land. And the topographic map shows that by using these contour lines. These brown squiggly lines are contour lines. And a map is a flat model of part of the Earth's surface that you can see from above. So it's a flat object, right? A two-dimensional thing that's trying to show us a three-dimensional object. The surface of the Earth has 3 dimensions, right? And we're looking at it from above. It's like you were a bird and you're flying overhead, and that's what you see on the map. So one really cool thing about a topographic map is that those little squiggly brown lines on the map, they show us something called elevation. Elevation is the height above sea level of a particular point on the surface of the Earth. So if we have the ocean here, this top of the ocean would be sea level. So here where the ocean and the ground meet, that would be considered sea level. And then the elevation is how high above sea level you are. Another thing that you see on a topographic map is a scale. So the scale tells you the relationship between the distance on a map and the distance on the Earth's surface. So for example, in this picture, this is not that far of a distance on the map, maybe like an inch or so on a map, but in real life, on the Earth's surface, that's 1 kilometer, which is just a little bit more than, or a little bit less than 1 mile, okay? So those contour lines, these contour lines are these little brown lines, all of these little squiggly lines that you can see on a topographic map. And normally you don't see those on like a regular road map or a Google map, right? These lines show us the elevation. These are lines that connect points of equal elevation. So for example, if I'm standing here on that dark brown line, I'm going to be at the same exact elevation, the height above sea level, as I would be if I were here on that same line. As long as I'm on that same line, then I'm at the same elevation above sea level. And I think about these contour lines like we think about with makeup and how you use contour makeup to highlight different parts of your face. Girls will probably know this a little bit more maybe than boys do, but maybe boys know this too. You highlight, or if you want things to show up higher on your face, you would highlight them in a lighter color. Like this lady on the right hand side here, her cheekbones, she wants them to look higher, so she gives them a lighter color. And the things that she wants to kind of fade into the background, then she makes those a darker color. And so we call that contouring, because what you're trying to show is you're trying to show those high points of the face and the lower points of the face. Just like you're trying to show elevation on a map, the high points of a map and the low points of a map. A lot of topographic maps will tell you what the contour interval is. On this particular map, they show you the contour interval right down here. Right, so that says CI equals 500. That's the contour interval, which is the change in elevation from one contour line to another. So if this contour line is 3,500, let's say feet above sea level, then the change as I go from this point to this point, I'm going to go up in elevation 500 feet, because this is 3,500, this is 4,000. If you take 4,000 minus 500, you're going to get 3,500. Okay, so that's a difference. And we're talking about elevations. We're literally going up in elevation, not just going from one location to another on the map. A lot of maps will also have index contours. An index contour is a darker line that sometimes it's labeled with its elevation, but not all the time. So for example, on this map, the 100-foot index contour is labeled with the elevation. The 150-foot contour line index contour is not. And then the 200 index contour is labeled again with its elevation. So these are darker lines that you can see are much darker than those other contour lines. You can tell that it just makes it a little bit easier if there are a lot of contour lines all in one area to be able to tell which ones have numbers and to be able to distinguish them from each other. All right, now you get to check your understanding of all of that vocabulary, see if you understand what we just learned. Again, if you are stuck, then you can always click here to re-watch some portions of the video if you need to before you click on the submit button. And then after you are finished submitting, if you get the right answer, then just go ahead and continue. But if you get the wrong answer, you might want to go back and rewatch some parts of the video to make sure you understand why you got that question wrong. Okay, hopefully you got those all right, and even if you didn't, as long as you understand them, that's the important part. All right, so next up we're going to talk about 7 different rules for contour lines. So number 1, all points along the same contour line are at the same elevation. Number 2, all contour lines eventually connect with themselves. So on this map, it kind of looks like those contour lines just end right at the edge of the map. But remember, we've zoomed way in on this picture of this little mountain that's here, right? We've zoomed way in on this topographic map. So if we could zoom out, if this is actually the map that is here in the picture, if we could zoom back out, we would see all of these other contour lines that are extending from that point where they ended at the edge of that map. Number 3, contour lines never cross one another. So you'll never see a map where 2 contour lines cross like that. This will never happen. So number 4, contour lines never split or branch. So if you are going along in your contour line and it's going along this way, you'll never see another one split off from that location. Okay. Number 5, contour lines bend or point uphill when they are crossing a stream. So in this particular map here, I have this river, right? I believe it's called the Moses River. I think that's what it's called. So the Moses River is here. Okay. Now as the contour lines are crossing the river, they don't just go straight across. So here's a contour line, but notice it's not just going straight across, right? As it crosses this river, it kind of points uphill as it crosses, and then it goes along. And you can see each one of these do that, right? So as they cross, they're going to be pointing in a particular direction. They are pointing uphill, meaning we know that streams don't flow uphill. Streams always flow downhill. So this stream must be flowing in the opposite direction that the that the contour lines are pointing in. So I'm going to say that again because that's really important. Whatever direction these contour lines are pointing, the river itself flows in the opposite direction. Number 6, the highest elevation for a hill is always going to be 1 less than what the next contour line should be. So on this map, or on this, I guess, picture, this very top contour line is 80. The one below that is 70. So they're going up by 10s. So the next contour line should be 90. But is there another contour line there? No. So the next contour line should be 90. So therefore the highest elevation is 1 less than whatever that should be. Since 90 is the contour line that should be next, it's 90 minus 1, which gives you 89. Okay, our last rule. Number 7, sinkholes or craters are shown by dashed lines. Sometimes they call them hatcher marks, or sometimes I'll just call them hatch marks. So these little hatch marks are right here, right? So you can see that these contour lines have these little marks that are going toward the center of this circle, right? These are called hatch marks, right? And they tell you that this is not a hill. This is a sinkhole or a crater. It's going down into the ground here. This one over here to the left, all of these contour lines do not have those hatch marks. So we know that this one's actually a hill. So this side over here is a hill, whereas this one on the right-hand side over here is a sinkhole or a crater. Okay, just a few more questions. Time to check your understanding. Make sure you're using your notes to answer these questions. All right, you're done. Great job. Just remember to bring your input page and notebook to class tomorrow to get a stamp.